Dear students, now we will learn that how we can panelize our printed circuit board. Actually, the panelization is basically making a duplicate of your PCBs so that it can fit multiple PCBs on a single panel during the manufacturing process. Actually, this panelization is done by the manufacturer nowadays, but you still have to know that how it is done. Now for doing the panelization, we are going to use the plugin that is kiKit. For installing the plugin, go to plugin and content manager of the KiCad, and over here the plugin we are going to use is the kiKit. In the search, let's search for kiKit. This is automation for KiCad and it will help us in panelization. So let's install this, apply pending changes, and it's downloading and operation completed successfully. Let's close this and let's close this one, and now you can see that in the install section that we have successfully installed the kiKit plugin. Let's just close this and let's make a new project, and let's save this on the desktop and let's name it as PCB Panelization, and let's hit save, and let's open the PCB editor. For using this plugin, kiKit plugin, it says no kiKit backend found. So whenever you find this problem after you have installed the kiKit plugin, the solution to this problem is that let's just hit OK, go to KiCad command prompt, click over here, and over here you have to write pip install kiKit and hit enter. Now it's it's now downloading and installing. Now it's done. Let's just minimize this and let's go to tools, to external plugins, and you see that there is no kiKit plugin yet. Let's just refresh the plugins, and you can see now that we have this KiCad show and hide references and KiCad panelize PCB. So this will help us to panelize the PCB. So the next step is let's run this tool. Click on this KiCad panelize PCB, and it takes a little time to. Now you can see that this is our window of the KiKit Panelized PCB. The first thing it's asking is the input file. Input file is actually the file which from which you are going to make the PCB. For doing that, click on the browse, and I have placed this file on the desktop, and let's just add this board file. Hit open. Now we added this file. The next thing is layout. Keep this layout as a grid, and I want to make 2 cross 2, and that I should have 2 rows and 2 columns, which means that I have 4 PCBs in a single panel. And let's give the horizontal spacing between the PCBs of 2 mm and vertical spacing of 2 mm. This is due to the manufacturing constraint that most of the manufacturers have the minimum capability of drilling 2 mm. You have the capability to drill of diameter that is of 2 mm. So that's why you can even consult with your manufacturer about this minimum drill size that they can drill. So I am going to use horizontal space 2 and vertical space 2 mm, and rows 2 and column 2. The next thing is source, leave it as it is, and the next thing is layout. We have selected the things in layout, then it's the tabs. In the tabs you go choose the fixed ones, and after the tabs the next thing you can do is the cuts. In the cuts I am going to, there are the different like V cuts, mouse bites, so I am using mouse bites for my panelization process. So in the mouse bites I am going to give the spacing of 1 mm and offset of 0.2 mm. Actually this is how the mouse bite holes are, how much the mouse bite holes should be inside the PCB. The next thing is framing is, let's say I want to use rail standard boundaries. This frame is actually the tabs around the border for pick and place or rails for reflow oven, so that they can be placed on some conveyor belt. I will show you the what the framing is, and let's keep the width 5 mm. And the next thing is fiducials. Let's say I am going to use 3 fiducials and horizontal offset of 2 mm and vertical offset of 2 mm. Fiducials are actually the reference point for pick and place of the components, that each component is referred from this fiducial point. So after adding this, the next thing that is very important is the post. In the post you can change this radius from 0 to 1 mm. Actually if I am going to use 0 mm over here, then the mouse bites will have straight lines, but if I add some radius then they will have a curved lines. So on the right side over here you can see that all the settings we have done are added over here, like the layout, we have done the settings of the layout, and for tabs, cuts, framing, and fiducials and post. So the next thing is, let's just click panelize and see how our PCB will look in the panelized view. So it's just taking a little time to, it's processing and panelizing our PCB. Now it's done. Let's just close this, and you can see that we have mentioned that we want 2 rows and 2 columns, which means we have 4 PCBs. This is actually 1 PCB, and now we have chosen 2 cross 2, that is why we have 4 PCBs in our panel, and we have chosen the horizontal and vertical spacing of 2 mm, which means that the distance between the both PCBs over here is 2 mm, and the distance between these is also 2 mm. And the next thing, we have chosen the mouse bites. If you go over here, these are called the mouse bites, and we have set the offset 0.2 mm, which means that these mouse bites, these holes are actually 0.2 mm inside the PCB. If you choose 0 mm, then these will be on this straight line. And another thing we have done in the post is that we have chosen the mill radius 1 mm. That is actually this radius that we have chosen. If we have chosen 0 mm, then this will be straight. Let me show you again. If I go to panelize, KiKit panelize tool, and I am going to change the post from 1 to 0 and hit panelize, then you will see that rather than there is a circular shape of the mouse bite, it will be a rectangular one. So it's just processing and making the panelization making the changes that we have just set. Let's just close this. Now you can see that this is the straight line, but it is some professional to add a circular shape over here, a round shape over here, so that they can easily cut this out using the drill. So I am going to change this to 1 mm again. So that was in the post section, and mill radius from 0 to 1 mm, and I am going to click panelize. So we have now changed again to round shapes. The next thing we have just set is the framing. Over here on the top you can see this one from this mouse byte above. Actually this is one rail over here, a frame rail over here, and the other is over here. At this place these are actually an extended PCB that will be placed on the conveyor while we are going to solder these components in a reflow oven. So these are the framings over here. The next thing we have done is the fiducials. So over here you can see that we have added one fiducial over here, which is 2 cross 2 mm from the reference, and similarly we have added another fiducial over here, that we have chosen 3 fiducials, and the next is over here. So while these fiducials will be helpful when we are going to use the component placement file for placing the components using the machine. So in this way we panelize our PCB. This is just for learning purpose, but actually this panelization is done by the manufacturer. You tell them that you need a panel of the PCBs, so they will do this work for you, but still you have to know that how this is done. Let's just look this in a 3D view. Go to view, and in the 3D viewer let's look how our PCB will be. So this is how our PCB will be when it is manufactured and assembled. You can easily break this PCB from this over here, from this mouse byte. Let me do this. So you can break this PCB from this mouse byte, or from here and from here. Similarly this one from this and this. In this way you panelize your PCB. Panelization helps us to speed up the assembling process, as well as the frames just added on the sides of the PCB will help us to put this on the conveyor belt and pass it into the reflow oven. So hope you have understood how you can install the KiKit plugin and you can panelize your PCB. These are just the basic of panelization. You can even study more about this and add more features to your panels. If you want to learn more about this KiKit plugin, go to over here at GitHub, KiKit automation for KiCad, and you can learn more about this plugin. And this is how you panelize your PCB. So hope you have understood how panelization works.